Good morning, guys. This is indices part 4. Under this part, we're dealing with decimal powers and bases. Okay. In order to avoid wasting of our time, we have two conditions under the decimal powers and bases. The first condition is to convert the power or the basis to proper fraction. So, like I said, this is the first condition: convert power or basis to proper fraction. Then the second condition is final answer may be converted back to decimal if you like. It depends on what you see in the option. So this is example. Okay, the first one, you have basis to be in decimal. Okay, you convert it to proper fraction. Then the power, which is minus 1 over 3, that is in fractional index. Okay, so that's fractional. Okay, and then you also have here to number 2, the base here is what, 0.25, and the power is minus half. But in this case, for number 3, the base here is 32 and the power is what, is in decimal. So let's quickly touch base with that. Number one is 0.27, which is minus 1 over 3. Okay, so what do we do to convert this one to fraction? Move this 0 3 times. 2, this is 1, 2, 3. So it's the same thing as saying 27 over 1000. I move it 3 times. That determines the number of 0 to use. All over minus 1 over 3. Okay, this is the same thing as saying 1 all over 27 over 1000 all raised to power 1 over 3. Okay, I've mentioned this when you have fractions under the power of indices in part 2 or part 1. Under the fraction, when you have um, minus 1 is the same thing as 1 all over, of that particular figure you're dealing with. But the figure here is 27 over 1000. So I've removed minus, it has turned to 1 all over. So it's part of the law of indices. Please go through them if you've not gone through them so that you can understand this part very well. So this is another law here. This is fractional index law. So this one is the same thing as saying third root of 27 over what, 1000. Third root of 27 over what, 1000. Like I said, that 3 root 3 is not the same thing as saying third root of what, 3. This is third, but this one is third root. Okay, please do not mix it up. I've mentioned it over and over again because in indices it's third root, not third. So what are we saying here? That we now have here, I can split this to be what, third root of 27, third root of what, of 1000. Okay, and this is the same thing as saying 1 divided by third root of 27 over third root of 1000. Okay, so I've said it that in sort, in part 1 in sort, I made mention of dates. Okay, you can go through it if you want to. So that if you want to change this division to multiplication, the denominator will come up. Okay, and the numerator will come down. This is denominator, this is numerator. Denominator will go up, the numerator will come down, which is the same thing as 1 times third root of 1000. Okay, over, that's third root of 27. It's as simple as that. So the question I ask myself is that, what can I multiply 3 times to give me 1000? Okay, that is 10 times 10, 100 times 10, that is what, 1000. So it means this is same thing as what, 1 times what, 10 over. This one is also the same thing. What can I multiply 3 times to give me 27? That is what, 3. So it means the answer is equals to, that implies that the answer here is equal to what, 10 over what, 3. If you look at this very well, I can leave this as decimal at the end of the day. This is the final answer. I can just say 3 3 3 can go here, 3 1, so it will be 3.333339. So the answer can be 10 over 3, or I can leave it as decimal to be what, 3.333. Okay, I can leave it as that. So that is what I mean by the second point here. The final answer may be converted back to what, decimal. So it means that this is indicating that the final answer can be converted back to what, to decimal. So it's as simple as that. So that is the first question. So I believe that that is very, very clear and is very, very straightforward. So we don't need to, beat around the bush on that. So for number two, let me quickly solve number two here. So for number two, we have 0.25, that's minus half. So this is the same thing as saying I'm moving the point two times. That's 25 over what? 100 all over minus what? Half. And it's the same thing as saying what? That's 1 over 25 over 100, that's half. Please go through all the laws in indices. It will make it easier for you to solve as many questions as possible. You can't escape indices in the exam, either in your schools, your respective schools, okay, or in your respective texts in the classroom. You can't escape it. It's very, very key. So I can say that this is the same thing as 1 over, that is fractional law. 1 over 2, that's root law now. This is root law. This is fraction and is root law. So this one, 1 over 2 is the same thing as square root of 25. Let me just, don't let me jump steps. Let me say square root of 25 over what? Square root over 100. Okay. This square root, that is 1 over 2, is the same thing as square root. And this is the same thing as saying 1 divided by square root of what? 25 over square root of 100. And it's the same thing as 1 divided by square root of 25 over square root of what? 100. Okay, I'm only just doing it like this because I don't want to jump steps. Okay, but now if I want to change this to multiplication, I can change this to the 1 times square root of what? 100 over what? Square, that's root 25. This means that what can I multiply 2 times to give me 100? It is what? 10. What can I multiply 2 times to give me 25? It is what? 5. 5 times 5, 25. So 5 here 1, 5 here what? 2. So that's the answer. It's as simple as that for number 2. So then if we've gotten that answer, let's do the one for number 3. Okay, we are solving these questions now so that you can understand what we mean by decimal power and basis. Okay, so we have number 3 here. This is what? 32 raised to power 0.2. Now the power here is what? Decimal. So it means that this is 32. I can also write this to be what? 2 over what? 10. I'm moving the point 1 times. Okay? Move the point to the back of the last figure. That is what we are doing. You move the point to the back of the last figure. In this number 1 here, we move the point to the back of the last figure, which is 3. The last figure here is 7, and we take it to the back. In number 2 here, we move the point to the last figure, which is 5. Okay? So that's why we are having 2, 0. But in this case, we move it to, which is 1. Back, the last figure there is 2. And we move it to the back, that's 2 over 10. So this one, the same thing as saying 32. That's 2 year 1, 2 year 5. So this one, the same thing as 1 over what? 5. And I can as well say this is fifth root. That's root law in indices. Fifth root of. So this is the same thing that is telling me that what can I multiply 5 times to give me 32? That's 2 times 2 times 2 times 2 times 2. So that implies that 5 root 32 equals what? 2. If you press your calculator, you will get your answer. It means 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So it means the answer is 2. It's as simple as that. Very, very straightforward. Okay. So yeah, that is all about decimal basis and power. So that's all about decimal basis and power. Please, I would like you to ensure that you share it to as many as possible so that the young minds or the students can see that mathematics is not hard. We are breaking it down into pieces so that the young minds can know that yes, it's very simple. All they just need to do is just to show interest, okay, and listen to it. Listen to all the parts so that you can flow along with the way it's being taught. Now, in part 5, we'll be mentioning exponential function. Okay, exponential function. We'll explain it for that. Then we do example on exponential functions. Then we can say yes, we are done with indices. Okay, so then before we can now move to the next topic. And although we'll have to solve as many questions as possible that we can lay our hands on, Of course, we'll share some other questions too that you can possibly say in your exams, so that you know that regarding mathematics, regarding indices, you are good to go. Regarding sort, you're good to go. Regarding factorization or algebraic functions, you're good to go. Thank you, and I'm very much thank you so much for listening. Cheers.